Okay, so now what we want to do is we want to take advantage of some of these properties that we use all the time in the background. These are meant to be mental math activities, but for the sake of being able to see what it is we're doing, we're going to write them down. But hopefully, like once you understand what it is you're trying to do, you get the idea of, well, this is how I do this in my head. Okay, a lot of it is like money and percentage based, which is good because that's like when you're out shopping and things like that, and you're trying to calculate the price of something or a percent off and things like that. You know, the ability to do that is just really good, just basic life skill math stuff going on. Okay, so we're going to apply a couple of these properties, mainly commutative, associative, distributive ones. We're not actually solving any equations here. So something like finding a tip. So let's say you go out to eat and your final bill comes out to $24.80. Okay, a standard tip to your waiter or waitress is usually about 15%. So if I wanted to do a 15% tip on this, it's pretty easy to do. Okay, because we can take that 15% and we can break it up into easy numbers to do. 15% by itself, no fun. Like I can't just look at this and know 15%. But what I can look at it and know is I can look at it and know what 10% is. Okay, because 10% is a really easy percentage to do because it just moves the decimal one place. Okay, 10% of $24.80 is $2.48. Okay. Well, to get 15%, that's 10% plus 5%. Okay, so I'm actually doing like the reverse of the distributive property here. I'm taking it back apart. I'm splitting 15 into 10 and 5. Okay. And now 5% is also easy, like finding 5% of this by itself, not so fun. But you realize 5% is just half of 10%. Okay, so half of this number is $1.24. Okay, so 5% of this is $1.24. Okay, so you could find 5% by itself that way. It's half of 10%. So 15% is 10% plus 5%, which makes $3.72. Okay, so if you want 15% tip, $3.72 is it. If you want to just end up in the ballpark of 15 to 20%, you just leave a $4 tip, and that's a good size tip that kind of fits expectations. If your goal was to go 20% instead, okay, we can always take a look at a percentage and try to figure out how to come up with a good way to split it up. So 15 is 10 plus 5, 20% would be just 10 plus another 10. Yes, we do 10% plus 10%. Okay, so 20% of this would be $2.48 plus another $2.48, which is what, $4.96. Okay. So it's good mental math and gets you doing percentages. Like again, you go shopping, you see something that's 20% off, you should be able to do that in your head pretty easily. Okay. Other common percentages, 15% really common, 20%, you could do 30%, there'd be 3 tens and so on. You could do something like 11%. Okay, so anybody who ever shops at Menards, especially at the moment, their 11% discount or rebate thing is running constantly. Okay, so if you want to find 11% of something, 11 is just 10% plus 1%. Both very easy to do. 10% moves the decimal one time, 1% moves the decimal twice. Okay, so if I wanted 11% of this guy, it would be 248 plus 0.248, which would be about 25 cents. Okay. And add those together and you get your 11% rebate. Okay. So 11% easy to do. 9%, I know one of the homework ones is a 9%. If 11% is 10% plus 1%, 9% is 10% minus 1%. Okay, so the same exact two numbers that I just erased, but you would subtract them instead of adding them. Okay, so it's just, again, testing your ability to sort of think about what a number is close to. It's like using estimation, but better because you can actually be perfect with it. Okay, so that's enough with percentage ones. Let's flip it around and just do pure money dollar ones right off the bat. Okay, so in example 2, find the cost of 3 items that are $2.55 each. Okay, so again, trying to do this without a calculator, I'll write it down so you can see it, but ideally you're getting comfortable enough where you can just do it in your head. This kind of goes to the estimation thing again. An easy number close to $2.55 that I can do math with is hopefully $2.50. Okay, so if I buy 3 items at $2.50, and then I have 5 cents to go. So that's $2.55. Okay, if I buy 3 things at $2.50, 3 things that cost $2.50, well, that's $7.50. Because if I were rounding, my estimate would be $7.50. But it's not hard to add on those extra 5 cents. Okay, so this is $2.50 times 3. Okay, and then that extra 5 cents times 3, well, that's 15 cents. Okay, if you put them together, $7.65. So buy 3 things that each cost $2.55. That's $7.50 plus 15 more cents for that nickel I rounded off. $7.65. Okay, so finding easy numbers to work with that are nearby, that's kind of a key to actually using, like I said, some of these properties and applying them to really good situations. Okay. Then example 3, again, if this is something where you're trying to get comfortable with it, you want to pause, you want to try it on your own, great. Otherwise, we'll just keep rolling. I want to buy 5 things that each cost $1.96. $1.96 times 5 is not a fun thing to try to do in your head. But what would be really easy to do would be to do $2. Because 5 things that each cost $2, 5 times 2 is $10. Okay, so this is going to be right about $10, but it's a little bit below. So it's going to cost me a little less than $10. Okay? Because to get $1.96, it's $2 minus 4 cents on each thing. If I'm buying 5 things and I'm taking 4 cents off of each, 5 things times 4 cents off of each is just 20 cents. Okay, so price will be right around $10. Subtract off that extra 20 cents, the little difference in there. Now we got $9.80. So it's great practice. It's just great basic math, applying it, using it, everyday stuff right there. And we can kind of wrap it into our properties. Real numbers, which is really cool to be able to do.